Gay Lussac's law states that the pressure of a given mass of gas varies directly with the absolute temperature of gas when the volume is kept constant. So here's the equation for Gay Lussac's law. And the two variables this is really relating is pressure and temperature. And they are going to be directly proportional. So basically what Gay Lussac's law is saying, it's saying that as temperature increases, so does the pressure. And just in the same way as pressure increases, so does that of the temperature. They're directly proportional. So you can use Gay Lussac's law for a lot of different things. As pressure increases, so does temperature. Think about a tire. Think about a car tire. This actually just happened to me recently in the winter here. So you have a car tire, right? Normally you have a place where you're going to pump in air on your tire. When it gets really cold, so it got really cold the other day, it was like negative 10 degrees Fahrenheit. The pressure in my car tires went way down. And the reason it went way down was because of the temperature. Right, so those particles inside of there actually started to slow down. So that pressure became less and less. Those gases occupied less space. And then now just recently it was 60 degrees. That's Chicago weather for you. But when it went back up to 60 degrees, those particles sped way up, and my gas pressure notification, or excuse me, not my gas pressure, my like tire PSI notification saying my air pressure was low, was gone because those particles sped back up. So let's do a practice problem. Find the pressure change when a constant volume of gas at 1 atmosphere is heated from 20 degrees Celsius to 30 degrees Celsius. So there's a couple key things to look at. Number one, we have 3 numeric values. You always want to look at those. And then you want to find out what's initial and what's not. So we know that there's an initial pressure of 1 atmosphere just by the context of the words, as well as that 20 degrees is the initial temperature, because it's saying it's being heated from blank to blank. So our equation is P1 over T1 equals P2 over T2. Now I just got to plug it in and solve. So 1 atmosphere is our first pressure, so it's just 1 over the temperature, which is 20 degrees Celsius. Remember, we have to put this in Kelvin. So that's just plus 273. So 20 plus 273 is 293. And that's going to be equal to P2. I'm writing P2 because I don't know the pressure value. That's what we're trying to find. And then 303. 303 came from 30 degrees Celsius because we converted that to Kelvin. So these are both Kelvin. And this is an ATM. All right. There's several ways teachers might teach you how to do this. I think it's easiest just to cross multiply, which is then going to give me, sorry, I messed up there, 303, because 303 times 1, and it doesn't really matter what side, you're going to get the same answer. P2, so that's going to be 293 times P2. Just got to do a little algebra here, so we divide by 293 on both sides. So 303 divided by 293, that's going to give me 1.03 atmospheres. All right, there's a couple ways you can figure out what quantity or what units this is in. I think it's pretty easy sometimes to gauge that from what the question is asking you. right? And we're also given two temperature values. So we're not looking for a temperature. We're looking for the pressure change, and I know this is my pressure measurement. So that's why it's 1.03 atm. So that's Gay Lussac's law. Thank you for watching.